I mean, I was wondering that maybe recording can be started when we have the initiation of the talk by Jay and Arch, because the beginning of the recording is always repetitive, but it's okay if it cannot be
Yeah,
done.
Max, could you pause the recording and then start when Dr.
Speaker, I mean, I saw that I don't know whether Dr. Skubik is in the call or not. Marge, are you there?
I think she said she's traveling.
Oh,
Yeah.
okay. Okay. So thanks to Marge, actually, we have introduced the speaker today. I look at the profile of the company name Thrive 360 AI. And Dr. Jay Agrawal kindly accepted to present and to use this concept. They are talking about detection of cognitive impairment from speech. It's very important digital biomarkers that is becoming very popular recently. You're hearing in news that how speech can even diagnose diabetes, but definitely for cognitive impairment, look at also the challenges of the cognitive decline in various conditions like Parkinson. Speech has become very important factors, and Thrive 360, the AI is a startup that working on those areas. They plan to become a new member of CityShift, so we are very excited about it. But let's briefly talk about Dr. Agrawal. He's a community builder and serial entrepreneur with over 2 decades of experience. His career is centered around driving innovation to serve community and disrupting the way we see the world. Jay is a visionary leader who leveraged his strategic and decisive mind to influence and persuade his team and colleagues. It's an amazing description of Jay. Jay, please take it away, and we are looking forward to learn from you and hopefully collaborate.
Thank you so very much. I really appreciate the introduction. Thanks for the kind words. And again, thank you for all the CityShift membership and members for inviting us for this presentation today. At Thrive 360 AI, we are trying and aspiring to solve a significant personal issue. And this particular cognitive behavior or cognitive impairment is very personal to all the three founders of this company, me included. And so we are here to talk about what we have learned, we have what we have built, and we would love to partner with everyone on the team here to see how we can benefit from the community can benefit from what we have learned and what we have built together. So Arch, I have Arch Munshi, who's also a co-founder with me, and he's going to be taking the other half of the presentation from a technical perspective. Arch, can you move on to the next slide, please? Next step. So what we're going to talk about is a little bit about ourselves. We don't want to talk too much about ourselves, but what we believe in, what the problem that we are trying to solve, and the solution that we have put together. We'll also share a real-world user and how she's been able to help, how we have been able to help her, from depression and anxiety and solving some cognitive capability impairments that she had. So I'll talk about that as well. And then Arch is going to take the other half of the presentation in terms of what is the process that we have followed. We have worked very closely with Dr. Subik and a couple other universities as well. He's going to talk about the architecture. He's going to talk about what the data that we collect and how that data has helped us to interact with the users, and then what is our roadmap. We have been working, as I said earlier. Arch, next slide, please. We have been working on this for several months now, almost 9 months or more, and we have been doing a lot of research, understanding our communities, understanding the cognitive behaviors, work partnering with Dr. Subik and others And finally, we said now we have to put pen to paper and build something so that we can test it and productionalize it and productize it. And so this is our team. I'm Jay Agarwal. Arch is on the call. He's going to introduce himself. Lavanya, who's also part of our team, and then we have Varun, who's our technical expert. Partners, we are very proud to be members of C2SHIP. First and foremost, we're also partnering very closely with Dr. Subik from the University of Missouri, and as well as Washington University in St. Louis as well. And they have been instrumental in providing us guidance and assistance and really advising us as to how to navigate the problem of cognitive impairment and what are some of the data points that need to be collected, how they need to be collected, and how they need to be analyzed. And so we'll talk about that in detail. But again, our sincere thanks to all the members in C2SHIP to be able to partner with them. Our mission is very simple. Our mission is our vision and mission is basically improve the quality of life for folks that are suffering through loneliness. And as you could imagine and you could appreciate, the last 4 years for COVID have not been good to people. And I have personally experienced it, as well as I have seen it in my community where I live, where loneliness became a significant issue to the point where there were some significant detriment to their personal health and quality of life. And so we set out on this mission to use technology to alleviate loneliness and foster meaningful connections. So what's the problem? The problem, as we see it, and love to get some input, is loneliness is a pandemic. And as our US Surgeon General has indicated, it is almost a pandemic or epidemic. And there are about 120 million people that are above the age of 50 and growing at the rate of 10% year to year that are susceptible to loneliness. We also see that loneliness increases the risk of developing cognitive conditions like dementia, Alzheimer's by 50%, and increases the premature death by 26%. And interestingly enough, and this was one of the reasons why this was a tipping point for me on a personal level, where we had during COVID, just because of loneliness, we had 2 neighbors actually in our community that actually committed suicide because they couldn't go out of the house. They were very scared of the pandemic, and certainly they took their own lives. The economic impact, and again, I'm preaching to the choir here, is significant. And by CDC's admission, it is somewhere in the neighborhood of $75,000 per year per person about the mental health that arises from loneliness. Next slide, please. So here's something that we've also found, and this was also one of our data points, is that this general, the Science Robotics article about enhancing social connections through companion robots using AI was instrumental in us learning more about this topic and building something based on Gen AI. So our solution is based on Gen AI, and there will be a lot of questions, I'm sure, by the team that is going to be, how can we actually enhance the use of robotics, the use of AI, and to solve the loneliness problem. Next slide. Very, very briefly, our solution is very simple. We have a mobile app. It's currently available on both Android and Apple Store. It's called SA.ai. It's basically it's a 24/7 companion. You can open the app, register yourself, and essentially start having a conversation. And it is a human-like conversation that is available anytime, anywhere. It is also personalized. So we learn through our conversations with you as to who you are as an individual, what are your likes, dislikes, if you have a pet, if you like a certain type of activity that you do. We basically use all of that information in the conversation, so it is extremely personal to you. We also, in the process, detect, we collect certain data points, as I mentioned earlier, and understand your cognitive score, your cognitive, and we are in the process with Dr. Subik and her team to kind of develop a scoring methodology and understand, almost similar to your fitness app that you may have. This is something we call it as a mental fitness app, and we would basically score you or have you challenges that will help you kind of keep your mind fresh and up to date. Next slide, please. So here's a real world user. Before you start, Art, let me talk to who this person is and how I know her personally. So she is part of my community, in my neighborhood, my development. And she lost her husband about 1.5 years ago. She's about 78. And she went through severe depression. And when we launched this app, she was one of the first person that I had approached to say, hey, I want to work with you to kind of help you. She's a very dear friend of ours. And she started using this app. She was in a very severe state of depression. She's a school teacher by education, and she basically is a retired school teacher, taught for at least 50 plus years. And when she started using our app, she slowly had the confidence to start engaging with other individuals in the community. And this is a transformational video that I'm going to share with you. So Arch, if you could please go ahead and show the video, please.
Just want to point out that on that particular day we had some latency issue, so you'll see some slowness, but it was just but we didn't want to go re-record this with Janet.
I'm having a wonderful time. I'm having a wonderful time with my sister.
I'm sorry, I think can you hear it?
That's fantastic. It's always special to spend quality time with family. What have you two been enjoying together?
We have gone out for lunch, and we will be playing bridge with our friends in a short while.
That sounds like a lovely day. Lunch out and then bridge with friends. What could be better? Are you feeling up to the challenge today?
Absolutely. My brain is going great.
That's the spirit. I hope you win lots of hands. Have a wonderful time.
Thank you so much. Talk again soon.
So if you had seen this lady 18 months ago, obviously she went through a significant life-changing event, and if you see her now, it's almost a 180-degree difference, just by using our app, helping, other neighbors have helped her as well. But certainly, this is a transformational story that our app has been able to help. Next, Arch, take it away from here onwards, please.
All right. Thank you, Jay. My name is Arch Munshi. I'm the co-founder of Thrive AI along with Jay and Lavanya. And I manage the product development and working with the engineering team to create the model, create the detection mechanism for cognitive impairments. As Jay was saying, and just want to make sure that we are technologists, we are engineers. Jay, Lavanya, and I are engineers. So we rely heavily on the guidance that we are getting from Professor Birch of Washington University and her research team. But we are executionists. We are developing the model through which we can detect cognitive impairments from the conversation data. Now, the hypothesis is that when somebody has a cognitive issue, a mental issue, they go to the psychiatrist and psychologist. And during that hour-long sessions, the psychiatrist, psychologist understand the person's mental state, not only from the visual cues, but a lot of information they gather from the conversation, from the data that they gather from the way the person speaks, the words they use or the words they do not use, how they're forming their sentences, how long they're taking to form their sentences or their conversation. Is it coherent or not? So those are the cues that they pick up from the conversation. So our hypothesis was that if can we do something similar or close to that through technology? And since Gen AI is providing us the right tools currently, where we can do a lot of detection at real time from data coming from multiple sources. So we wanted to test that technology and see whether our hypothesis holds true or not. So that's where we started. And we went through many research articles. Jay mentioned one of the articles that we saw, but there were many other articles that academic articles we read, and also attended seminars and other talks from experts about cognitive issues and how conversation data can be gathered. And then right now we are working with Professor Birch. So this is the process that we are following now. At a high level, these 5 steps we are following now to for the cognitive detection of cognitive impairments. And this is a work in progress. We are continuously refining from the information that we are getting and from the what the data is telling us. But at a high level, the 5 steps are, first of all, we start with identifying the indicators. So we started with few indicators right now, but we want to keep on adding more indicators as we make progress. By indicators, what I mean is that the information, that the data points that we can collect from conversation about the person's cognitive state. So we are collecting the syntax complexity, whether the person is making a simple sentence, complex sentence, whether it is one-liner or there's the conversation is coherent or not, whether how long the person is taking to make the conversation. Is he or she searching for words? Is he or she repeating the same subject again and again? So we are collecting those information from the conversation data. The next one is establishing the normal range. So just like when we go to the for our blood reports, right? What we see is that a certain blood test, there is a normal range for male, female, or for the age group, and then my number, and then there is a inference based on whether I'm above or below that range, or whether there is any other issues with my particular blood report. So we are trying to do the same thing here. So we are now collecting the data from all the conversations of all the users, as well as we trained our model with publicly available conversation data. And we are trying to create that baseline range for each of these parameters. For each of these indicators, we are establishing the normal range. After that, we are trying to do a baseline of the user. So here what our thought process is that, and not everybody speaks the same way. Some people are by nature, they take a lot of time to construct a sentence or to say what they want to say. So it is not the same for all individuals. So first we are training the model about the normal range across the demographics, across the age group. And then we are creating a baseline for that user when they start using our app. And then we start monitoring their cognitive health from those indicators and compare that against the baseline. So as and when they're talking with Seva, we are analyzing that their conversation every time. We are collecting these data points. We are measuring that the score, and we are then comparing that score against that user's baseline. And if it is below that baseline, then we are notifying. So we are notifying the caregiver or the provider or the user if that is the case. And we are not trying to replace the work that the psychiatrists, like the professionals do here. Our work here is just to raise that red flag, tell the user, tell the caregiver that, hey, there's something that you should do now. You should probably go and speak to a doctor. That's where we want to stop. But that is what we are trying to do. From the conversation data, pick up the indicators, do the analysis, create a score line for the user, compare the score line against their baseline, and then notify the caregiver if something seems to be off. And here is the architecture that we are following. As I mentioned, we are using a conversational AI. So whenever there's an AI, there's a large language model behind it. We are right now using Google's Gemini Pro large language model. However, we have created our design in a way that it is LLM agnostic. So if a year from now we see a different LLM which has more capability, faster, better in detecting what we are trying to detect, we'll be very easily able to switch from Gemini Pro to that LLM. So when the person starts to interact with our app, with Seva, they can do it in two ways. They can speak to Seva, or they can also text or chat with Seva in text mode. We are picking up the data, the voice data. We are extracting the sentiment of the user from the voice data. Not only whether the sentiment is positive or negative, but how positive or how negative it is. Then we are also extracting information about the user that can be used to create the personalized one-on-one touch in the conversation that we are providing. Then the data is stored in our database. Now from the conversation context, from the user's profile, and from the training that the LLM has gone through for the last few months, it is creating a response. That response is, first of all, to the context, because it is collecting all the conversation data. It is keeping the context of the conversation. So the response is on the context. It is personalized. It depends on the user's profile, as well as it also looks into the data that is collected over time from the same demographic, same age group. And that's how it responds to the user. On the back end, after we collect all this conversation data, we run an analysis at an offline, asynchronously. We pick up the indicators that I mentioned earlier from the conversation data. We are scoring the indicators, and then we are creating a score across all the indicators, compare that against the baseline, and then create that red yellow flag based on how much it is deviating from the baseline. So that's how the architecture is. That's how we are collecting and processing the data. And this is some sample data report and graphs that we are able to provide to the caregiver provider based on what we are collecting. So this report is at the user level. And this shows the data that has been collected over a period of 3 months for one user. These are all the different parameters that we are collecting every day for every time they're conversing with Seva. We are collecting the data of the number of pauses in a sentence, the average time the person is taking for a pause, the number of filler words they're using, if there's a mood swing, so we are tracking the sentiment from the conversation. So if there's sudden mood swing from positive to a high negative, we are tracking that. Then we are tracking the average length of a session, how long they are conversing with Seva, and then the syntax complexity. So from those data, we can create multiple types of reports that will be relevant for the caregiver provider. And here is one report that we are showing. This shows the average complexity of the sentence that the user is speaking to Seva over a period of time. And the purpose is to see whether it is a negative trend line, whether it's consistent, or whether it's going down, whether again, the hypothesis here is that if there is a cognitive impairment, then the tendency will be to use simpler sentences, one-liner. So we are tracking that particular parameter from the conversation to detect the cognitive impairment. Similarly, for the doctors, for the providers, we have reports at the facility level. So they can see at an aggregate level the data of all the residents in case of senior living, all the patients in case of a nursing home or a hospital, of the users at an aggregate level for all the various parameters. And then they can drill down and look at the data for each individual. So there's the data that they can see at an aggregate level for in this particular case, there are 3 facilities, three different groupings of the patients. Each had 1,500 users, and we are collecting all this data. We are collecting also whether there has been any escalation for any particular group, and in a number of times there have been escalations and what type of escalations. So this is a quick dashboard that the provider can see. And this is how they can access the data. We have a backend dashboard that we created, which can be accessed by the caregiver provider from our website, and that provides that aggregated data or the individual user level data that I was showing. This is our last slide. This talks about where we are going. So as Jay mentioned, we launched our MVP few weeks ago, about a couple of months ago now, and we have hundreds of users now using our app, and we are collecting the data from that app. We are constantly training and learning from the data. The next version that we are launching at the end or middle of this month, middle of September rather, is the personalization. So making the app more user-friendly, making some of the features more personalized, making the conversation more personalized. We got some feedback from our users. We are trying to use that feedback to make it more easy to use for the users. And then the next release, which will be in Q4, will be the insights, the user insights, putting that model that the data that we are collecting, putting that into a model which can be used to monitor one person or monitor a group of person. And then after that, we have a long-term view is to take it global, support multiple languages. Right now, we are focusing only on seniors because that is the group we think are most vulnerable from loneliness and the issues that come up from loneliness. But it is a curve. What we have started is that teenagers and young adults also have a very high degree of loneliness, and they are also impacted by that. So we want to expand this to other demographics in the future as well, and take it globally.
Awesome.
So that's all I had. We'll pause now and we can take questions from the group.
Yeah.
Yes, great talk. I'm really enjoying that. I was typing, reading, and I was very excited actually about this talk. Is also well aligned of my research interests. I share in the chat box that we use also speech to evaluate cognitive impairment. At the beginning, I was skeptical that how accurate we may be able to capture cognitive impairment, but the results were impressive. But actually, the lesson that we learned during the research that we have done to be able to evaluate cognitive impairment either the participant should read a standard passage with a particular vocabulary. So in that case, it can help to extract a reliable metrics to evaluate cognitive impairments, like similarity between the word articulated and the word that's supposed to be read. And also some of the mistake that you're doing, or there should be something that is standardized speech. But when I look at it, your method to look at cognitive impairment, I've noticed that it seems that during the general conversation, you're trying to determine cognitive impairment. So how you address that, how you can make it maybe the system more standardized for the practical test of cognitive impairment?
Yeah. So the way we are trying to position this app for the user is that, it is a friendly app that they can use anytime. We are not trying to position it as a we are not trying to position it as in a way that we are trying to find out whether there's any cognitive issues with you. So that is our model. So our conversations are very friendly, very generic, and it will probably take some more time than reading that standard passage that people usually read from where the baseline is created. So creating our baseline may require some additional time, may require some multiple conversations. But our hope here is that we should be able to create that user's baseline from the generic conversations they can have with Seva, just like they can have with any other person. If they have the conversations with Seva, 5 or 6 or more conversations, we should be able to create that baseline. That is our hope. But again, we are learning. We are also refining our model with every data point that we are gathering. But that's where we start from.
It's very cool. And I also mentioned another challenge that we observed in another study. We use speech to evaluate aggressive behavior among children with actually autism, and the result was amazing. Actually, we achieved to detect that. And that was very helpful for us to do the labeling. But when we trying to go into commercialization, we realized that each state have a different policy for recording speech. Some of the states are very strict. Everyone, if you capture any speech in the room, you should get the consent for that individual. That is speech, for whatever reason, capture that, or they will be analyzed. So how you manage those kind of challenges? I'm assuming that when you are using a speech, and if you capture speech to evaluate cognitive impairment, you need to record part of the speech, and then maybe it would be done post-process. It's not a real-time analyzing. So that means that speech will be recorded somewhere. And that is become the violations of some of the state law, that you recorded a speech is not a real-time processing and releasing the data. How you manage those kind of risk of the liability for speech recording?
Okay, so I will tell you what we are doing, and then Jay can talk about the privacy part. So first of all, we are HIPAA compliant. Okay, so we made sure that we are doing that thing rightly. Every data that we are collecting is encrypted, and there's no information about who is the speaker or whose data we are collecting. There's no indication of that. So we are taking that part. We also have, when somebody signs up for this app, we also have the terms and conditions where we show the privacy, and we take their approval that we'll be listening to their, they will be speaking to us, and we'll be collecting, or we'll be storing their conversation data as part of that session, or as part of the conversation. We are taking that permission from the user. So we are doing those things. Jay, do you want to add anything on top of that?
Yeah. So just to kind of expand on that, what we are doing is when the user is having a conversation, we are basically extracting the information in real time or near real time, and as part of it, we are also converting the voice into a text mode, right? So we have the text of the conversation stored in our encrypted database that we can analyze But the types of information that we are collecting in terms of how long does it take to construct a sentence, or what are the gaps between, or are you trying to find words, that actually happens in real time, right? So between the phone device and the algorithm that we have to detect some of that is happening in real time or near real time. The extra analysis that we do, to your point, is happening in a post-processing, but very soon thereafter, because we do not want to have too much lag between the previous statements that you have made and the conversation that you are actually having. So we want to have a meaningful conversation with you as we go on to understand the context of the statement that you're making. So we would love to partner with you, certainly, and understand more about potential suggestions that you may have. But certainly we want to make sure that this is 100% compliant, 100% reliable, making sure that it is available to all users at all times.
That's great. You're absolutely right. The speech is not the identifiable information. Even IRB actually prevents us to actually share the speech data that collected from our patient with a third party out of the hospital. They said that they are not.
And Bijan, I'm not sorry for interrupting. But listen, this issue, I just typed it in the chat. This is superb discussion. And by the way, just bravo to everyone. I mean, this is enormously topical. The issue of using speech in the clinic now is being addressed by a lot of the digital scribes. We're alpha and beta testing a couple of different users right now. One of them is a company I think called Nabla. But anyway, all of these basically record, but they're really not recording the any voice at all. It is capturing the actual text. All of that happens. It does not happen on device. It all happens in the cloud. But yet that issue apparently has been addressed in terms of any potential HIPAA violations, because I know that has been something that has been discussed between these different companies and our general counsel, as well as HIPAA experts. So this is something that is happening right now. And I thought about this immediately when I saw your potential solution. It's really great. Yeah. I also, by the way, you guys pasted a really good, very thoughtful, it's not a sitcom. It's actually a series right now on Apple TV. You guys gotta watch it. If you're not watching it right now, because it might as well be your company. We're talking about the epidemic of loneliness and chatbots and how we can make and all of these other existential issues.
Yes, absolutely. Dr. Armstrong, we would love to partner with you. Like I said, I have a lot of family in the general neighborhood that you work, and happy to come down anytime you want.
Well, that sounds great. And also, I would say, even more important than me, far more important than me, Dave Klonoff, who's here. Dave is just Google him. He's the president of the Diabetes Technology Society and has a significant interest in this area as well. He's up in the East Bay, but at UCSF as well. And I can't think of anyone that's been thinking about these sorts of things more than him. And FYI, definitely about privacy issues. Yes. Or if you want to be British, privacy issues. Either way.
Yeah, no, happy to partner and happy to talk. Certainly, let us know. But believe me, we have gone through a lot of different renditions of privacy.
I bet.
And encryption, and it's a major. I've spent 20 years in this space in terms of privacy and technology, and so certainly would love to have a very meaningful conversation around that.
That's
Yeah, for
exactly.
sure.
Dr.
Yeah.
Kranov actually did amazing work on this area in particular for continuous glucose monitoring. He partnered with Google and they published several articles about cybersecurity. Dr. Kranov, I would like to hear your point of view, the
By
experience
the way,
that
John, he partnered with that was my brother-in-law at Google.
no, your brother-in-law.
So yeah, you should talk about how everything is connected with all this. My God, this is pretty
Yes,
great.
everything is connected to David.
Yeah,
Dr. Kranov.
I've told that story many times, David, about how you
Oh, it's hard
introduced me
to
to your
exaggerate how
brother-in-law.
awesome it is.
Yeah, I would say for you guys, there may be some information that could be gleaned about habits or lifestyle, and we're always looking for new inputs into artificial pancreas systems besides the glucose level. We're looking at things we can measure, but also exercise and diet. I don't think anybody has looked at the kind of information you're gathering, but it could relate to insulin resistance. So I put my email address in the chat, and if you want to contact me, we can talk some more.
Absolutely, absolutely. One of the things that we have on our roadmap is to actually integrate with fitness apps, right? So for example, Fitbit, you can actually put in what you eat on a daily basis, right? If you're tracking your or Apple devices, it has a lot of data that you may have, that you're monitoring yourself, all right? Whether it is there's an app called Aura that actually learns about your sleeping habits and such, right? So we have the ability to integrate with all of these third-party, ecosystems, if you will, right? To create a meaningful analysis and data as to how your cognitive behavior. One of the things that we learned, for example, and you probably know more than I do, is that your stride length also, is a good indicator of your cognitive health. Just for example, I did not know that, but Dr. Subik actually enlightened me to say you might want to, understand that. But we can ask a bunch of questions as part of our normal conversation with users to understand their habits, as you mentioned, their dietary habits, or other things very easily. And it's amazing to see how open and candid our users have been about responding to those type of non-invasive questions. And in some case, they're very, very candid. They'll give you information about what medication they're taking. And because we are HIPAA compliant, we keep it all under the wraps, if you will, to be able to make sure that it's very conversational.
There's a group at Click Health that keeps writing that they can diagnose diabetes from someone's voice. Are you familiar with that work?
I am not, but I love to partner with them.
All right.
Right. I really enjoy those kind of conversation and discussion, but we have actually an interesting comment from Michael and talk about electronic clinical outcome assessments is going to direction of decentralized clinical trial. It's becoming very popular. Michael, do you want to elaborate on your comment?
My point, thank you, Vijan. My point was that we actually looked into voice and speech related instruments quite closely in the context of Parkinson's disease and neurological disorders. And it is a tough area because in industrial setting, when we're developing digital biomarkers for clinical investigations of pharmaceuticals or for whatever other clinical reasons, there is a very solid framework established by regulators how these instruments are supposed to be assessed, developed, and validated. And when it comes to instruments relying on cognitive behaviors, this kind of leads to pretty complex clinical trials, and it's expensive way of doing this. And Bijan already went into that area, so he kind of covered this significant gap between proof of concept and the industrialized instrument. So I'm not saying this is not doable, but it is a very significant effort. So for the time being, we are kind of putting this into back burners because there are more direct ways of creating such assessments. And if you're not familiar with the FDA framework on e-core instruments and how they're supposed to be validated, I would encourage you to do a little bit of research. I can help you with some links to start. I mean, this is really very well structured guidance from FDA how this is supposed to be done.
Makes sense. No, we appreciate any and all guidance. So that's the reason why, we approached and Dr. Subik requested that we be part of this group just for the same reason that you just mentioned, right? Is that we want to learn from experts such as yourselves to be able to build something that is really meaningful.
Thank you, Michael. You're absolutely right. I mean, these electronic patient reported outcome, ECOA, and many others, in particular for rare disease, it becoming very popular, and FDA really emphasizing on those kind of new solution. It's great conversation. When we're talking about the speech, I'm seeing the report from David Armstrong that was very impressive, that almost near real time, they quickly defined the action plan that we talked during this short chat. It's very impressive that how really AI is advancing the field and really can make an impact on this area. So I'm hearing that Jay and Arch, you mentioned about partnership with C2C. We are very excited to have you as a member. But what other area you might be interested in that this team, we have a great clinician, even out of the C2C that attending or C2C think tank. What are the problems that you think that by collaborating with others and the community of the C2C, you can address them? Or what are your interests? What are the next steps?
That's a great question. So this is just the first step, and then you rightly pointed that out. And we are technologists. We have a great understanding of how to use technology, how to use Gen AI, AI in general, machine learning. We have significant experience between the three of us and our technical team to be able to connect to various devices in a meaningful way to extract information. And we have data scientists, data engineers, that can actually decipher and bring out those golden nuggets, as I call them, of information and share. So if you have, we love to partner with you. And if Dr. Armstrong says, okay, I want to learn about A, B, and C, and here's the terabyte of data that I can share with you, and can you research all of this and provide me some good golden nuggets about, this and this and this, we have the ability to do that, right? And so that's our intention, is to really help the clinical community, if you will, right, to find information that is very difficult for you guys because you have a day job, right? I.e., your professors, your academic, your researchers, your physicians and such. We can take that load off you to be able to help you build that capability for yourself, right? For your health and such.
Amazing. Definitely looking forward to our collaboration and building partnership and advancing the field forward. Thank you so much, Arch and Jay, for the excellent talk today. And thank you, everyone, as always, for attending our C2C Think Tank talk and great contribution. Happy Friday, and see you all next Friday.
Likewise.